Right.
There we go.
All right. Now we are recording so we can say profound things and know that
Yes.
they will be saved.
Yes.
Um, okay. So here's the point I kept getting stuck on that I could never quite bring my thought map all the way to see what was happening, which is that
Hmm.
I want to be able to connect our approach to Hawking's approach and to, how people do it today to think about it in real research. And And the anchor point is the fact that our static model, we get the same result for the mass as a function of density that Hawking gets, right?
Hmm.
And yet, they're totally different pictures, and I was just really struggling to figure out, well, what does it even mean to line them up, right? And
Hmm.
and and our whole, like we
Yeah.
wanted to be able to make, like it looks sloppy what I have written in the paper right now about the slices that we've talked about.
Hmm.
And like, well, what does it even mean to compare? Why do we have any business taking a slice at a certain density, doing our static model and saying what size black holes would form and having any reasonable connection to the fact that in the real universe there was a time that had that density for a brief moment and like why there's any connection, I guess, right?
Hmm.
And so but the piece I was stuck on is how to think about and the I think the thing that helped solve it was when we brought in the Friedman equation finally yesterday,
Hmm.
right?
Hmm. Hmm.
And realized, oh,
Oh.
yeah, we need the actual physics of the expanding universe to be in here. And the thing that's interesting
Hmm.
about it, right, is that I mean, the curvature ends up mattering for this because
Hmm.
if it's if it's flat, you're not going to form a black hole, right? I mean,
Right.
if K is, we're so used to doing cosmology with K is zero.
Hmm.
But if we're
Hmm.
trying to do it in a little clump, K is most definitely
Yeah.
positive
Not zero.
because
Yeah.
that's what's going to make it so that R dot over R can become negative because there's a minus K over R squared term in the
Hmm.
Friedman equation, right?
Hmm. Hmm.
So, so what I was struggling with then was trying to map the my intuition about um, the actual expanding universe, where in order for any of it to have any place to hold stably, you have to assume a uniform density everywhere, right? So that you can talk about
Hmm.
the whole universe doing the same thing. That's the whole isotropy and homogeneity.
Hmm.
But so the punchline is it it just sort of more intuitively than before it was just intellectual, but now I have that intuitive sense of, oh, there's an expanding space, R dot over R, that's equal to basically rho, right?
Expanding spaces because
So, if you look at
of
the
the
Friedman equation,
uniformity and isotropy.
yeah, right. If you look at the Friedman
Hmm.
equation and take all the distracting terms off, including the curvature for now, right? It's just R dot over R quantity squared is 8/3 pi g either rho or rho over c squared, depending on how you define rho.
Hmm.
And then it's something like plus lambda over 3 and minus k over r squared. Right. I mean, it depends on your
Hmm.
units, and yeah, the units are weird, so I'm not sure exactly how to. But it's something like that, right?
Yeah.
But the important thing is that there's at least a simplified case where it's just r dot over r is equal to the square root of 8/3 pi g rho, or rho over c
Hmm.
squared. Yeah.
Hmm.
And
Hmm.
so the expansion rate is proportional to the square root of the density.
Hmm. Expansion range for, yeah. The more dense it is, the faster it's expanding.
Yes, there you you now share my
Whoa.
my moment of insight, right? Because it's a there's an initial condition, there's an
Uh-huh.
expansion rate. And in order, so it's like um, the confusion that I see on your face that I feel internally is the same thing as imagine you are looking at, imagine I threw a ball up in the air,
hmm
right? Not a ball, but
Your AirPods.
symmetry arguments need to be made
Yeah.
here.
It's a
Um,
spherical cow.
yeah,
Fine.
this will link you up with this is a sidebar, but this will link you up with the other thing I was reading last night was the energy condition thing, the singularity theorems. I found a good
hmm
book by Bob Wald, who was one of my professors at Chicago.
Oh, yeah,
Um,
wait.
Robert Wald,
Yeah,
Gravitation.
Chris tried to give me that,
Oh
or
yeah,
at
yeah,
least
yeah,
a
yeah. You should
textbook
you
that he
should let
ran.
her. You should here
Yeah.
just a second. Yeah, I really like the cover.
Oh yeah, no, that one exactly. Yeah.
The flat table on top of an apple.
Yeah.
That's like the essence of general relativity. Only people who know. I mean, there's probably only a few thousand people in the world who get that joke. But
Wait, I don't know if I get the joke.
okay, I'll
Table.
welcome you into the fold of
Okay,
because
cool.
because the nature of general relativity. I mean, I guess I don't know that I haven't asked Professor Wald about this, but I assume um, because the whole nature of general relativity is the idea that in small enough regions you can approximate a curved surface as a flat surface.
Oh yeah,
And
uh-huh,
so the
uh-huh.
essence of a curved surface is an apple, and the essence of a flat surface is a
Is a
tabletop.
table.
So, yeah. Um,
That's really funny.
anyway, but he has a chat. I won't forget what I was actually going to say here, but
Okay.
um, he has a chapter on just what you were talking about yesterday that I think from your class. Um,
Oh, the positive mass theorem.
yeah, the positive mass theorem. So I highly recommend his section on singularities. Where did that go? I was
I
reading it.
wish I stole it. She gave it to me for a while, and I think I tried to work through the beginning of it, but it was really
Yeah,
hard.
it's I mean it's hard going. And he acknowledged the other reason I was going to recommend it for you is because he acknowledges the dauntingness of the I guess I could use the index uh, the dauntingness of the mathematical formalism that's needed to understand these
hmm
things, and because he's explaining how he's going to approach it. But um, okay, here we go. Chapter 9 is called Singularities. And he does a really good job of setting up why there's a problem. Remember when you were asking me about the null geodesics and all that sort of stuff? The null
hmm
geodesics are just paths of
Light.
massless particles, light or
hmm
whatever.
hmm
Um, and he does a really nice job of explaining why there's a puzzle having to do with singularities. And it's because when we're used in classical physics, Newtonian physics, when we talk about a singularity, because we have a background space-time to work within,
hmm
we can
hmm
talk about the point in space-time where the singularity occurs, right? So if I put a point charge
hmm
at some coordinate location in my Cartesian space coordinates, right? X equals zero, Y equals zero, seven letters, Z equals zero, T equals zero, right? Q equals zero,
Which
whatever
one?
else you want to. Actually, I don't want Q to be zero because I want to
Oh,
charge. So I want a
yeah.
point charge at X equals Y equals Z equals T equals zero.
hmm hmm
If I put a point charge with a charge of, one electrostatic unit there, then there's a singularity at the origin of that coordinate system in terms of the electric field strength, right? Because it blows up because it's one over
Right,
R.
because
So
it's at the
it's because it's at the origin, right? Of R
charge.
equals zero.
hmm
So I can ask, where is the singularity? And I can say it's at the origin of my coordinate system, right? Or, you put it
Mm-hmm.
anywhere.
Mm-hmm.
But when you're talking about relativity, the mathematics is describing the space-time, the filing
Right.
system. And so you need a way to talk about what you mean by a singularity that you can't really say where is the singularity because the singularity has to do with the inability to define where,
The
right?
singularity has to do with the inability to define. Yeah.
Because
Yeah.
where is
Yeah.
the coordinates. And so
Mm-hmm.
anyway, so he just has a really nice conceptual discussion of that that then leads into it. It gives you context for understanding probably what I'm guessing you're doing in this class without knowing what you're doing with all the math. So all the things like because basically the the issue that I never fully understood before that came up in the foundations of this field when people started exploring what general relativity meant is that um, it's pretty easy to show that if you have a spherically symmetric mass that collapses on itself, it will form a singularity.
Mm-hmm.
But there was legitimate uncertainty for a long time about, well, in the real world, you never have that perfect symmetry. Your star is a little bit misshapen. That's what made me think of it
Mm-hmm.
was this is not
Misshapen star.
a. So, and in Newtonian gravity, if you think of the same kind of thing, if I have a perfectly spherical mass distribution that collapses on itself with a pressureless like dust, they usually
Mm-hmm.
call it in cosmology things, dust meaning that it, like what Hawking was talking about, it doesn't have any
The
pressure.
relativistic.
Yeah.
Mm-hmm.
So that you can just let it collapse in free fall.
Mm-hmm.
There, um, all the points will go to all the bits of matter or energy will go to a point, a singularity. But if you mess with that symmetry even a little bit, then that doesn't happen because they'll go past each other, right?
Mm-hmm.
They won't all get to the central point at the same time, and they'll
Mm-hmm.
pass through, and you don't actually get a singularity. And
Mm-hmm.
so there was a thought in general relativity that it might be the same thing, that unless you have perfect symmetry, then you don't actually get a singularity, and that you're sort of safe from
Mm-hmm.
doing that. So all of these theorems about like the weak energy condition and the positive mass condition and
Mm-hmm.
those sorts of things have to do with there are proofs within the structure of the mathematics of general relativity that if certain conditions hold on the metric, which of course are related to the conditions of the energy and mass density in the
Mm-hmm.
region, then you can prove that certain kinds of asymmetries will still go to a singularity.
Interesting.
And that's what, I mean, that's what
Positive
the,
mass
the
theorem.
yeah, the importance of that is what was being recognized when Penrose was um, picked for the Nobel Prize, right? It was
Mm-hmm.
for the singularity theorems that sort of
Mm-hmm.
settled mathematically the the question of whether singularities would actually form inside. You knew there was a horizon, but you didn't
Mm-hmm.
necessarily know that inside that horizon that you would be, sort of smushed out of existence at
Mm-hmm.
a point. And singularities don't have to be, I think this is true, like in the Kerr solution, singularities don't have to be at a point. Singularities can
Mm-hmm.
be torus shaped or whatever. They're just places, they're descriptions of regions of space-time
Mm-hmm.
where
Values
and,
go to
yeah.
infinity.
And so, but again, in general relativity, those what it even means to have a singularity has to be defined in terms of the the paths of geodesics and what happens to
Mm-hmm.
them and whether they get away or not or whatever. Because you
Mm-hmm.
can't
Mm-hmm.
you can't talk about a singularity at a point in space-time because there's not a point in space-time to talk about.
Yeah.
So
Yeah.
like a
So
singularity.
like the theorems like positive mass theorem and stuff were people's attempt to show that singularities can form even without asymmetries or even without symmetries.
Correct. Correct.
Okay.
That's my
Wow.
understanding. And
Yeah.
and the reason, I mean, there do have to be conditions on the energy. Just like if you can have a negative energy density, I think some of those
hmm
theorems don't work.
hmm hmm
But it seems reasonable to think, so that's why people are very interested, for example, in like if you want to make a wormhole
hmm
to travel through, you need exotic forms of energy, like negative energy density, because those
Oh,
prevent a singularity. Those allow the
okay.
wormholes to stay open. And again, I'm out of my field here, so I might be,
Yeah.
I might not be stating the details with precision, but I think that's the
hmm
gist of,
Okay.
yeah.
And I do have to leave at
Yeah.
3, but also this came up in therapy and I wanted to ask about your experience.
Yeah.
Like how do you become confident in what you know to be
Agree.
true?
That's a,
Like how do you like I mean obviously, there's always going to be some degree of, this there could be something I'm missing to like invalidate this line of reasoning. But
right.
like how
Go ahead.
how do you like how do you be confident in your logic and line and reasoning and like how do you like convince yourself to be confident with like your line of reasoning?
Yeah, that's a great question. Um, so answer number one is you ask that question a lot.
I do.
No, 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 no. Sorry, no. I mean,
In general, the royal
the answer,
yeah.
your question. Sorry, I didn't mean. This is the first time I've heard you ask that question. It's very well
Yeah,
stated.
I was gonna say
No, what I meant is you're asking me a question. How do you do that? How do you
uh-huh.
become confident? And my first answer to your question is you become confident by asking yourself the question that you just asked a lot. Does that make sense? Like that's my advice is ask that question a lot.
hmm
Because if you're thinking about it, then you're filling in the dot, like then you're aware of where the gaps might be, and then you're thinking about
hmm
filling in the gaps to,
hmm
so that's my first thought is that it's really good to ask that question because
hmm
if you're asking it, then you're doing the things that you need in order to become confident, and if that makes sense, right? That's not
Yeah.
my only answer. That's just my starting point. So
Yeah.
don't
Yeah.
worry.
Okay.
There will be more useful things from that. Just keep asking that question over
Keep
and over
asking
again.
the question.
Um, so that's my first thought is actually, put that on one of your note cards
hmm
and sort of practice it with things. I It's hard. It's really hard, especially because it's really easy because it depends on your surroundings and your mood and
hmm
the people who like if you're giving a talk and you're very confident at the start and then people look at you with puzzled looks like you've lost your mind, then you become quickly unconfident and then you're
hmm
like, wait, do I know what I'm talking about or not? Um, I think though the main thing, let's see, this can be an ongoing discussion. So, but I think the main thing is ask specific questions because I think a lot of the places where I find myself losing confidence is because I lose track of, wait, what am I? There's too much. There's too much
hmm
information, and I'm just like, so for example, if I just pick up a book
hmm
that I haven't looked at for a while with, things that I'm not familiar with in the immediate moment, then
hmm
I can lose confidence pretty fast because I'm just assuming that I need to know all this information,
hmm
right?
hmm
Whereas if I give myself a problem that says, um, I don't know, I'm just making up something up off the top of my head. Um, I see a satellite orbiting the Earth, and I
hmm
time it, and I find out that it takes 3 hours to orbit, and it's in a circular orbit. How high is it above the surface of the Earth?
Hmm.
right? For most people, that would be a very daunting question.
Hmm.
And yet, kind of like we did in advanced analysis, right? I have a sense that, okay, I'm going to write down what I know. I'm
Hmm.
going to relate the variables and I'm gonna get an answer. I mean, I don't know the answer off the top of my head, but I'm very confident that you give me half an hour and a chalkboard and I will tell you the answer and I'll be
Hmm.
confident of it
Hmm.
because I know the background steps and I know how to
Right.
frame it. You know what I mean?
Hmm.
Um, so I think the main key for me is always when I start feeling overwhelmed and unconfident, especially when I'm in an environment with other people who are smart and potentially very arrogant and, and like to
Hmm.
show off or
Hmm.
whatever,
Hmm.
right? You
Yeah.
know, in other words, in the physics environment, as it often
Yeah.
is. Um, and they're doing their thing for their purpose. I have to find an anchor, which sometimes means going off by myself and finding an anchor where there's something that I know I understand that I can start from to connect to
Hmm.
whatever it is that they're trying to do, and
Hmm.
connect it to something that's meaningful to my frame of concepts, kind of. Um, so I think that's a huge key is learning how to focus your attention on bite-sized pieces that you can wrap your mind around.
Hmm.
Because there are so many things I can so easily set up a question for myself that I have no idea how to answer, and I'll just get frustrated because I go down tracks and I realize I don't even know,
Hmm.
you know, I'm not even sure I understand what space is anymore by the time I get to the end of
Hmm.
it, right?
Hmm. Hmm.
So I think the key to building confidence is to practice biting off little pieces
Hmm.
and saying, "Oh, I can I can do this." And then I can
Hmm.
use that to anchor myself where, okay, I know, I mean, I know I can do something.
Hmm.
And then, okay, well, what if that assumption that I made to do that simple problem isn't true? Then what changes or whatever? And then I can start kind of, you know, there's this blizzard of the snow is blowing all around and I can't see anything straight. But if I can find a solid piece of ground where it's not a drift of snow and I can put a stake there and tie a rope to it, then I know, okay, I've got a place I can go back to. And then
Hmm.
everything else is a blur, but there's a place I can go back to that I'm confident of. Like I know
Right.
that's there.
Right.
And then, kind of like we were doing yesterday as we
Hmm.
were floundering with wait, what do we do to find the gravitational potential energy in this situation or whatever?
Hmm.
We kept going back to, okay, you wrote down what you know, which is GM1 M2 over R.
Hmm.
And then, well, how does that relate in this situation? And then we discovered, oh yeah, we actually need an integral in this case to do it and all
Hmm.
that sort of stuff, right? Um, so I think the confidence mostly comes from being mindful of the steps that you've built and knowing how to reframe a problem so that it connects to the steps that you've built so that you have a place to
Right.
stand again when you start feeling lost. That's
Right.
kind of that's kind of what I find. And sometimes I forget to do that and then I just feel lost for
Hmm.
a while and then
Hmm.
oh
Hmm.
yeah, wait a minute. I do know something here. Does that
Okay.
that kind of make sense?
Yeah, no, I think that's one of the reasons like why this is like me trying to like read the textbooks and like work on the problems and stuff. I think I keep getting wrapped up in like all the like you were saying with like the when you were referencing the Wald book, even though not necessarily the Wald book specifically, but like there's like so much information in here, and like if you just had to like you know all the information, like
Mhm.
that's just not. I think I approach like the textbooks with like, oh, I like should know all of this stuff or
Right,
something,
right.
and then I just get really frustrated when trying to like work through the textbooks and the problems. Um, and then it just ends up becoming like too much and like emotionally, so then
Yep.
I have a harder time getting myself to do it because
I see you.
yeah,
Yeah, that's
it's
really well articulated, Logan. I mean it when I say that like the most important thing is to keep asking yourself that question because that's not an easy thing to articulate. it's a common thing to just feel awash in, but
Mhm.
it's not an
Mhm.
easy thing to like, you know, go to the meta level and watch yourself and see, okay, this is what's
Right.
happening, right? It happens to
Yeah.
all of us, but it's
Mhm.
not easy to articulate. So that's, you know, kudos, and
Thank you.
that's helpful
Yeah.
that you can do that should give you
Mhm.
hope, right? Um, yeah, yeah, and it's related. Honestly, I didn't have it quite that well articulated, but that's why I gave you that like second grade math book or whatever. It's sort of
Mhm.
it
Yeah,
was
that's
meant to
right.
be symbolic, right? Of like
Uh-huh. Uh-huh.
of just when you feel overwhelmed, go back to
Mhm.
something that you know. And I
Mhm.
felt very
Mhm.
confident that no matter
Oh,
what mental state you were in, that would
yeah.
be something you would go back to and you'd be like, oh, I know stuff,
I know
right?
stuff.
And so
Yeah.
it is. It's really useful. Another thing, honestly, is um like find find a network of if you're interested in this, like tutoring,
Mhm.
like basic math
Mhm.
for people.
Mhm.
Um, is another example of where, because then you realize that stuff that you just treat as automatic, like that you know how to do
Right.
algebra or whatever, it doesn't even seem like a
Mhm.
skill to you. For for a lot of the world, that's sort of a life dream of being able to understand how to do those things.
Mhm.
And
Mhm.
so being in that conversation where they don't even know how to solve what you would consider a simple equation, and being able
Mhm.
to explain to them and get them to the point where they do understand that is really helpful for being confident in what you know, because you're aware that not everyone knows that. You do know
Mhm.
it, and you know it in a way that can convert someone into kind of knowing it, at least
Mhm.
temporarily.
Mhm.
So I find that useful of just like remembering, not just being lost completely in your own world, but
Right.
kind of just comparing, not in a sense of competitiveness, but just,
Yeah,
just
but
just
just
just reminding yourself that not everybody
showing
knows the things that you know.
being exposed to a new perspective.
Right, right. And a
Mhm.
perspective
Mhm.
that doesn't have the knowledge or the skill that you have.
Yeah.
Um, um, yeah, but I think the main thing is, sorry, one more thing related to what you just said is that
Mhm.
I still get frustrated by this, but I just acknowledge it. So, and I think it's a
Mhm.
hard thing to learn early on, is that part of the reason I need to make sure I have enough quiet time.
Mhm.
I had this thought the other day that, I have enough insights that have happened in the few decades I've been working on these things, that I kind of have this sense now that most of the things I want to know about have come through my awareness at one point or another, like
Uh-huh.
the pieces are all there.
Mhm.
And so I had this thought the other day that I wrote down, which was that I think what I most need now to understand the things I want to understand is just to be quiet enough for long enough for
Mhm.
everything to fall in place, is the way I said it.
Hmm.
And and what I mean by that is not like complete isolation and silence or
Yeah.
something, but just there's something that happens when I'm still, but I have all the bits and pieces around me
Mhm.
that I rediscover. That's what I'm getting at for your question, is that
Mhm.
I don't know all the things that I know all the time.
Mhm.
In fact,
Mhm.
most of the time I don't really know any of the things that I know.
Mhm.
And I've used to find that really frustrating, right?
Mhm.
Like especially when I get really busy in the semester, like a year or two can go by where like I'll have some really profound insight that I'm like, okay, yes, I've got it now. And
Mhm.
now I just need to finish that off and piece it into other things. And then, five classes have to be developed, and, advising happens and all the thing, and then all of a sudden a couple of years have gone by, and I find it in my journal. I'm like, oh yeah, I wanted to think about that, but I haven't known it for the last 2 years or something,
Yeah.
right? And
Yeah.
even stuff slips away, while I'm on sabbatical, it's easier to notice because I go
Mhm.
through cycles of where I'll work on some question or issue and I'll really get deep into it. Like I was understanding the fine structure constant the other day, which is the E. the electric charge E squared over H bar C. You know, not an important detail for now, but
Hmm.
my
Hmm.
point actually was that you're probably reaching in your mind like, wait, what's the fine structure constant again? And how does that?
Uh-huh.
And I remember, so in this moment, I was struggling to even find what the expression for the fine structure constant is.
Hmm.
But 3 weeks ago, I spent a whole day writing notes on understanding what that means about what quantum mechanics says and the nature of space-time and why that's an important thing in our overall picture of the universe or whatever. And I felt like, oh, I'm going to be sad when this slips away. But and
Yeah.
it does, right? Because I have to go,
Hmm.
because then
Hmm.
then I have to figure out, what this particular equation on page 76 of Hawking's paper means. And I get lost in the details of that. And then I don't even remember what the fine
Hmm.
structure constant is
Hmm.
anymore, but it's still there. It's it's
Mm.
it's
Yeah, no, I've noticed that I also like yeah, no, the same like I feel like a big worry that I have generally, but especially like going into this gap year is like having all of those things that I learned in undergrad, like just like slowly slipping away and me not really being able to do much about it unless like,
right.
because I just have to kind of go through those classes again to like hang on to those things, like constantly like work with those things. But I watched a video recently um about like learning and well, it was actually this video in combination with an article about reading in a different language
Hmm.
where like the points where you realize that things have slipped away and you like you're in a situation where you need that information and you realized it slipped away and you are like actively putting your brain through discomfort to recall the thing
Hmm.
that had slipped away.
Hmm.
That is learning.
Hmm.
So like you're doing like you're in a way kind of supposed to forget those things so that
You're
you
building
can
pathways.
yeah, so you can engage repetitively in those pathways so that like feeling of like frustration and like discomfort and like I mean well I guess the frustration you don't have to have it's just the frustration that
Yeah, I mean, there's always
we
going to be
kind
at
of
some level
normally
of
have
frustration.
but
You can try to keep it at just the level of an immediate like reaction to it's like you've come up against something. It's just like an awareness that you've come up against something that isn't smooth,
hmm
whatever, right? But yeah, no, and I think that's really good perspective. That think of that's what you're doing when you learn something, and it's. I mean, you're lucky in a way. Well, in today's world, I won't assign judgment or value about it, but
hmm
in today's world, the distractions of having everything, devices and having everything on the internet or
hmm
whatever, of course, hinders our ability to focus and concentrate. So we have to kind of consciously
hmm
develop that. But if we can do that, the really nice thing is that it's way easier to now just all you have to do is remember the path. You don't
hmm
you don't have to
hmm
remember all the information, right? I mean, so
yeah
so all you need to remember is that, oh, I need the Friedman equation for this.
hmm
And when we're working on it last spring, when you were doing your project and we were developing the things, I could have pulled the Friedman equation in all of its detail and all of its nuances out of the air at any time, right? And then
hmm
when we were
hmm
talking about it last night, I had some vague sense of what it related, but I
hmm
couldn't. I mean, but it's an easy Google search to just go and what's the
yeah
Friedman equation, and and they're still learning, even if you don't remember it, there's still learning that happened about you're familiar with it. Like you said, you have
Mm-hmm.
pathways and you know how to
Mm-hmm.
manipulate it and what it means, and you have a different level of understanding. So yeah, I would, kind of focus your learning on building those concept maps, right? You're trying to
Mm-hmm.
build a sense of connection of what I think that's why I was suggesting the note cards and stuff, right?
Yeah.
You're trying to
Mm-hmm.
build uh, a framework of what are your questions, what is the kind of information that you need to answer the questions, and then because you really do, I think, just have to. I mean, maybe other people's minds work differently than mine, but I think from what I've seen, I think you and I probably have about as much ability to keep all the things in our minds as anyone, right? I mean, if
Mm-hmm.
anything, most
Mm-hmm.
people
Mm-hmm.
have less
Right.
ability to sort of keep it all framed, if not rather than more. So I find that I just have to keep, whether I do it in a journal or a kind of a mind map, concept map, I just have to keep something, some framework to keep orienting myself
Mm-hmm.
so that, and then just being aware that I can only do one thing at a time. And when I'm doing that thing, I forget about the other things for the
Mm-hmm.
moment. And
Mm-hmm.
I'm just thinking like this big history conference. There was a whole bunch of discussion around, my talk and how we were going to do the
The spreadsheet
developing
thing.
the spreadsheet and stuff like that. And I wrote a bunch of stuff down so I can go back to
Mm-hmm.
it. But a few days later, I moved on to the music chapter in the physics foundations of physics or the everyday physics book and moved back to our stuff.
Mm-hmm.
And all of that is mostly gone from my mind from the big history conference now. And yet
Right.
when I was in the moment of doing it, that was where I had the impact, right? Where I was having a
Mm-hmm.
conversation and had. So I think that's part of it too, is you try to boil things down to where you can have insights and pull them all together and then write something.
Mm-hmm.
Submit a paper or teach a class or get some stuff packaged
Mm-hmm.
and say the thing. And then you sort of just have to acknowledge that, okay, in a few days or weeks, you're barely going to even remember that thing, but now it's out in the world
Mm-hmm.
and it's doing whatever it's going to do, and you can circle back to it
Mm-hmm.
because I think it's hard to fully accept that there's just so much more to think about than we can hold in our awareness at once.
Right.
And we're always going to feel, the parts we can hold on to are always going to be so tiny compared to the whole
Mm-hmm.
that it's always going to
Mm-hmm.
feel like we're not confident that we know anything at all.
Right.
You know?
Right.
So, so
Yeah.
I, so I think the psychological answer to your question is to repeatedly carve out little bubbles within which you feel like you know everything.
Mm-hmm. Mm-hmm.
And that's my
Mm-hmm.
ask a specific question. When you start feeling overwhelmed, does that make sense? You are
Yeah.
if you let everything in, you are going to feel overwhelmed no matter what.
Mm-hmm.
Because no matter how
Mm-hmm.
hard you study and no matter how focused you are and how hard you work, if you allow all the information into your mind, you are going to feel very unconfident that you know anything because most
Mm-hmm.
of that information is going to be stuff that you are not going to know or have at your fingertips or have
Yeah.
the ability to. So I think the psychological solution to feeling confident
Mm-hmm.
is knowing how to carve out little bubbles of that
Mm-hmm.
to, that's like the analogy I've heard, which I've probably told you before, is if every time you sat down to eat a meal, you thought about all the food you were going to have to eat in your life, you would be so over, and you thought about how you were going to accomplish eating that amount of food,
Mm-hmm.
you would be overwhelmed. But you don't
Yeah.
do that. You just put a few things on your plate and you arrange them nicely and you think of how beautiful it is and you
Mm-hmm.
breathe it in and think of how good it's going to taste and how nice it smells. And then you have that one little plate full of of food and you feel very confident about that
Hmm.
meal that you've prepared and you feel
Hmm.
confident in the sense that you know you can eat that and you're going to enjoy it.
Yeah.
But you do it by isolating things that you can
Right.
wrap your mind around. So I think from a
Yeah.
psychological
Hmm.
standpoint, I think that's the practice is
Hmm.
to find some, keep drilling down because we have good days and bad days and
Hmm.
if things you could do yesterday aren't working today, drill down to a smaller piece until you find something you can do, and then that builds your confidence up, and then you can
Hmm.
build on that to, do more things.
Hmm.
Like if you've
Hmm.
been sick and you can't eat what you normally eat, you try eating a saltine cracker, right? See how that goes, and then that builds your confidence that you can eat other things. And that's not a great analogy, but sort of
No,
just
I think it's a good analogy. Yeah. Yeah. It's funny.
yeah.
Yeah.
Let's keep
Okay.
talking about that because that's a good
Yeah. No, it's funny because like you like you definitely said the things that I needed to hear more than my therapist because my therapist isn't in this field.
sure.
But both of them had like a big message of taking a big thing and breaking
Make
it
it.
down into smaller chunks. And like I know that, and that's like something that
Uh-huh.
like I do, but it's not like I don't have a process, I guess, for
Mm.
like in this
Yeah.
specific case, at least. Like I have processes of doing that in different situations, but I guess right now I'm trying to figure out how to do that.
Yes. So let's try something really specific. Actually, I'm going to try this too.
Hmm.
So when you're reading something that you think is important or interesting and you're trying to understand it and you feel that whatever, maybe it's not panic, but that kind of overwhelmed sense
Anxiety.
that comes up.
Yeah.
Anxiety is good, right? Right. Try, maybe even just have something written down on your desk on a post-it note or something as a reminder.
Hmm.
Try to find a specific question that you can ask about whatever the topic is
Hmm.
and see if you can answer that question. And then keep
Hmm.
keep revising that process to a more and more specific question until you find a question you can answer,
Hmm.
right? And even, I mean, the question might be, why am I reading this? This
Hmm.
is
Hmm.
painful. Why am I reading this? And then that at least gets you onto something concrete. Like, well, I'm reading this because I want to know how to do this.
Hmm.
And then, okay, well, then what's a smaller step I can take to doing that? Like why am I reading this paper? Because I want to understand how primordial black holes form.
Hmm.
Well, I can't follow this paper on how primordial black holes form.
Hmm.
So what if what if the universe weren't expanding
Hmm.
and I had
Hmm.
a clump of matter? How would I answer the question then about whether a primordial black hole was going to form?
Hmm.
Well, I still can't answer that. Let me go read something about what defines a black hole. Okay, now I have a
Hmm.
criterion. This
Hmm.
Schwarzschild criterion thing. Now I have a
Hmm.
formula for that. Okay, so now can I turn
Hmm.
that into it? You know what I mean? Like just keep
Hmm.
keep going, and then you have something where you can say, okay, now I know what we're
Hmm.
doing, and then now let me go back to this paper and let me see what they're doing and see if it's analogous somehow and like where the things blend together. Or maybe you find out that you don't actually need that paper because it was not
Hmm.
answering the question that you wanted to answer. I mean,
Yeah.
I think just making it really active and tied to a question that you want to know something about,
Hmm.
and then tying that to an action that you can take. Because
Hmm.
I think that's ultimately where the confidence, right? I
Yeah.
mean, I think that's the thing to boil down. Confidence comes from doing something
Hmm. Hmm.
successfully that
Hmm.
you thought you couldn't do.
Hmm.
right? I mean, I'll give you an example that Jenna could tell you. I mean, it's been sort of a joke, but it has actually bothered me, right? Because I'm so
Uh-huh.
used to being good at things and like I
Mm-hmm.
can do stuff, I can do whatever. I could not do these freaking mudras, right? I mean, it was just like first I couldn't even make the shapes with my hands.
Uh-huh. Uh-huh.
And then to try to do them as fast. I don't know if you watched the
I haven't
thing
watched it
yet,
yet. I
but
completely
yeah.
forgot.
So, but it's fast and it's transitioning from one to the other and doing it in
Hmm.
rhythm
Hmm.
and
Hmm.
it's just not something that comes naturally to me at all.
Right.
And so I had moments where it was just probably how most people feel about taking our physics classes, right? It's just
Hmm.
like I don't even know this language. I don't know how to make my psyche have a reference point to even know when should I do this versus this.
Yeah.
I
Hmm.
just I can't
Hmm.
even
Hmm.
it's not I don't even know
Hmm.
where to start.
Hmm.
And yet you break it off into bite-sized pieces. And I spent a whole weekend one time trying to record videos of doing and I'm still not good at it,
Hmm.
but I can mostly do them in rhythm and make the transitions and pull out of the air like, oh yeah, when this sound happens, then I'm supposed to switch to doing this and then back to
Hmm.
this and then then
Hmm.
this and all I can
Hmm.
I can roughly do it. And it's something that felt like I don't even know where to begin to be able to do that. So
Hmm.
if you can have those
Yeah.
kind of concrete things in your mind, I think ultimately, like I still don't know the difference between why I was able to do it one moment and not able to do it another moment.
Hmm.
But the action is what gives me the confidence. Like now I know I can do it because I've
Hmm.
done it. So the
Hmm.
same thing of like you can sit there and think, well, I can't understand these equations or whatever. So find something that you can calculate and calculate it. And then when you
Hmm.
start having doubts, you have something really concrete to go back to, which is just say, yep, I don't understand how any of this is possible. And yet I know I have an anchor point. I know that last week I actually wrote down this equation and I solved it. Like
Hmm.
you can't take that away, right? So I think the confidence
Right.
comes from action. So
Right.
doing something that you
Yeah.
thought you
And
couldn't do. So that's why making smaller chunks matters because eventually you
hmm.
find something you can actually do, and that's where the confidence comes from, I think.
Hmm. Hmm. Yeah, that makes a lot of sense. Thank you.
Yeah, no, thanks for the question. That was a really good question.
Yeah, it's just like, I'm trying to figure out how to do this, I guess, like how to prepare myself for tubing in. And like I'm like trying things so that I'm like it's not working,
Yeah.
but I think that's just because I'm like taking these huge chunks and I'm like
Yes. Yeah.
like
Well,
what yeah.
and keep in mind that I was thinking about this yesterday as I was reading things and imagining what your experience is going to be. Keep in mind that I think part of the benefit of a program like Tubingen is it's going to give you the structure. I mean,
Hmm.
it's gonna create for you. I mean, just like hopefully we did at Pacific, right? I mean,
Yeah.
it's gonna create for you, each class creates for you a structure that's gonna continually challenge you with things that make you feel anxiety because you don't know
Hmm.
them. And then scaffold, you're gonna do problems and you're gonna be able to do it. And then you're gonna not
Hmm.
know something and then you're gonna be able to do it. And I mean,
Hmm.
we in these programs bite off chunks for you
Hmm.
in a sequential, hopefully reasonable order and amount to to build that. So in preparing, if you can just relax a little bit and have the idea that you're just exposing yourself to all the things so that it'll be a little more familiar and a little more, that process will be smoother and less anxiety because
Hmm.
more things will be familiar. And if you can have that attitude so that you don't feel like it's not like you have to learn it all before you get there. You're
Hmm.
just you're just smoothing the transition by being familiar with it. So even even
Yeah.
if you just know what you don't know, then
Hmm.
you're better able to
Yeah.
say, yeah, when that comes up in lecture, you can be like, yeah, I saw that when I was trying to read the general relativity book on my own, and I didn't understand it then, and I still don't understand it.
Hmm. Hmm.
Can you say that a different way or something? You know what I mean? Like you'll know
Hmm.
for sure that you really find that a challenging topic because you'll have found it challenging before and it's still challenging. So you're going
Yeah.
to ask about it.
Yeah.
Whereas if it was the first time you'd seen it, you might think, oh, it's just part of the blur of everything. I don't know if that's something I
Hmm.
need to ask about yet.
Hmm. Hmm.
So if you just treat it as it's going to help you to be exposed to the things. Um,
Yeah.
and like
Yeah.
doing our research
Just
is going to help because
exposure.
then you have something specific where you know what it means to apply it rather than just yeah.
Yeah. Okay, wait, hold on. I need to write
Yeah,
down.
go for it.
Do you hear the hissing?
What's that? The hissing?
Do you hear the hissing?
I don't actually.
Um,
Must be filtered out by the, whatever the response of the microphone is, may not pick
oh,
up those
true.
wavelengths very well.
My mom could hear it when I was FaceTiming her on my
Oh,
phone, but that was my
okay,
phone.
okay.
So
Huh. Oh wait, but you have your ear pods in though, right?
true.
So
Yeah,
I probably can't hear much
right.
from the ambient noise.
Okay, well that's good that you can hear it because I can.
I'm sorry that
Okay,
you have to,
fine.
but
Oh, that's okay. It's fine.
you're
It's
used to
just
it probably.
yeah. Okay. Okay, well I have to go in two
Yeah.
minutes.
So can I just maybe in the last 2 minutes? You
Hmm.
really do have 2 minutes? Yeah. I mean, is
I
that okay?
mean,
I mean,
roughly
it's
two
okay to
minutes.
you don't have to go now, I guess is what I'm saying, right? You still got two
Yeah, I
minutes.
don't have to go
Okay.
now.
Well,
Hmm.
so just to close the loop on that thing I started the conversation with.
Hmm.
So in our static model, having a given density means you can find a
Hmm.
radius where there's a black hole that collapses, right? And the thing I was struggling
Hmm.
with is that in the expanding model, clearly there can be density that
Hmm.
doesn't result in black holes because the density is actually proportional to the expansion rate, right? In the
Hmm.
Friedman equation. So
Right.
it finally made it click. Like, so then there's the question of, well, why does our model give anything reasonable? And what I'm realizing is that it's the density fluctuations then against that background that matter for the expanding
Hmm.
case, right?
Hmm.
You're basically it's almost like you're creating a
Hmm.
little pocket that has its own Friedman equation where it's not flat, right? You're creating a little pocket where if you did the Friedman equation just in that little pocket, your density is way higher.
Hmm.
And so the expansion rate will actually be lower somehow. And I mean, I don't understand yet how all this works, but at least I can see that, okay, I need a density. That's why I need a density fluctuation in an expanding
Hmm.
case, is because I really need there to be a region that's much more dense or that's more dense. And
Hmm.
that's going to then mean that in that local little pocket, the expansion rate is going to turn around and fall back in, right? So the K is like positive in that case. So,
Yeah. Is
but
that why? No, you. Sorry, you continue. You continue.
well, but if I want a rough marker for what the size of those fluctuations are going to be, it's going to be much easier. It's easier to have a fluctuation that's of order the already background density, right?
Hmm.
Whereas like the cosmic microwave background fluctuations are like one part in 100,000
Hmm.
fluctuations, and those aren't going to be nearly big enough, which is why people are worried, which is why people say that in order to have primordial black holes of any consequence form, we need non-scale invariant fluctuations that are, some mechanism for producing more fluctuations in some of those papers we were reading.
Hmm. Hmm.
But it
Hmm.
it finally made it click that, okay, at least it's reasonable to order of magnitude. That's why our thing works, is because the densities that we come up with in our static model are at least order of magnitude the same as the density fluctuations that are needed in the expanding model. But the
Oh.
fluctuations are going to be kind of order the the background already, right? Like if
Hmm.
I need an overdensity of whatever 50 million grams per cubic centimeter, and the background density is only 1 gram per cubic centimeter, that's almost impossible to get that fluctuation. But if the
Hmm.
background is already 50 million grams per cubic centimeter, then a relative fluctuation of another 50 million isn't so unreasonable. So I
Hmm.
think that's the basis for why our approach kind of works. And I think so
Yeah.
finally knowing that, now I feel more confident in the spirit of your,
Hmm.
now I feel
Hmm.
more confident about saying something about that in that narrative in section 4, because I was floundering because I didn't, I just felt like I was hand waving too much. Um,
Hmm. Hmm.
anyway, so that
Yeah,
was
and
that
I
was my
mean,
point.
I guess is that why Hawking says,
I know
um,
what you're going to. It's top of page 76, right?
yeah, that if these collapse regions are not to be
To be
completely
completely
disconnected
disconnected
universes on
universes on
their
their
own.
own. The
Yeah.
mass in them must not be so large as to close them off from
From
our
our
universe. I've
universe.
pondered that for a long time, and I'm not exactly sure what he means by that, because I think we need them to collapse in order to be black holes, right? So I don't, if they're not to be completely disconnected universes on their own.
Well, I think okay,
Oh, I
like to
see.
to no, you go.
You go, you go.
Okay, okay. I was gonna say, like initially when I read that, I was like, oh, maybe during that time period, some people had theorized that if regions were massive enough, they were different universes on their own, and he was just kind of
Right,
referencing people thinking that. But I like kind of the idea of the opposite of what he's saying, of like having like disconnected universes, like not necessarily actually being disconnected, but considering them or labeling them to be
yeah, yeah,
disconnected,
yeah.
because then like you said, you can have those pockets with their own Friedman equations because like the curvature is different.
Right,
And like for us, then how we're connected to that is that our model is one of those disconnected pockets
right, right. So I
with
think
their
that,
own
yeah,
Friedman
yeah,
equation.
right, yeah. What you said is good. It's the same thing basically as what I was going to say, which is that and I think that was part of why I was fuzzy on it. So it's nice to have him just acknowledge that it is fuzzy. Like,
Hmm.
if you're talking about these things forming, how do you tell the difference between whether it's a black hole in our universe or just another universe? And
Hmm.
the answer
Hmm.
is those aren't completely disjointed ideas,
Yeah,
right? I mean,
like a black hole is a different thing.
it's just a question of how big it is, right? So the same argument that if something is pinched off from another, if I think what he's saying is if those masses are so big that they're like effectively whole other universes, then that's just
Hmm.
going to be like pinched off, disconnected universes expanding at
Hmm.
different rates.
Hmm. Hmm.
And so, this is why we're talking about a few times the stellar mass down to asteroid masses or whatever. Those are going to be small enough that they'll still be in non-disjointed regions.
Right.
Of our own. So anyway, so all of this is just making me much more confident that, okay, we can say the things that we've been saying, and that's useful. Also, I reread some of Barbara Ryden's book last night, and
Uh-huh.
the language she uses when she derives the Newtonian version of the Friedman equation is a
Hmm.
lot
Hmm.
like what we're saying. Like she has the caveats in there about how, well, of course, in the Newtonian sense, this isn't fully realistic because you'd need to have empty regions outside, and we're trying to talk about it with the whole, so
hmm
just the fact
hmm
that she's saying stuff like that makes me think, okay, this isn't going to get, you know,
Pushback.
hammered by reviewers or something for even talking
Hmm
this way, because we're just trying to build intuition, and there's a precedent in well-established textbooks for talking this way and stuff. So, in fact, we might even consider referencing that
Yeah.
as a framework for how people can think about this. So, yeah. So, okay. So, as you have time, definitely feel free to keep fiddling around with trying to get what Hawking got, but
hmm
don't feel pressure or don't feel inadequate if you can't do it, because there's clearly a lot of assumptions he's making that aren't being
Yeah.
written down,
hmm
and we don't really need it to be able to say
Right.
what we want to say in
To
our
finish the
paper.
paper.
But just it's
Yeah.
just fun to play with. So,
Yeah.
but
Yeah.
yeah,
Cool.
okay,
All right. I did play around with it a bit, but I kind of want to take a break from it and
yep,
then come back to it.
yep.
Okay.
All right.
Cool.
So I mean, if we
Well,
don't get a chance to talk, which we probably won't because you fly back day after tomorrow, right?
yeah. Yeah.
Yeah.
And you'll be at the beach,
And
right?
I will be hopefully, although right now
Yes.
there is no
Oh, right.
access
The
to
atmospheric.
Gerhard. Like Jenna called and she said that there was flooding that had shut down Highway 101 up there.
No.
So we're gonna, and maybe it'll be better by tomorrow, but
I hope
um,
so.
see. But anyway, so yeah, safe flight, and
Thank you.
let me know. We have a plan for next week,
Hmm
and we'll have
It's in my
chalkboards.
calendar somewhere. Yes.
We'll have fun. And
Yes,
then
yes.
oh, is it one quick thing? Is it okay if
Hmm
we do our coffee
hmm
with
Ashley?
Ashley? Is it okay with you if I invite Jenna?
Oh, yeah. Yeah.
Since
Yeah,
we're
for
doing it in
sure.
person. Okay, because I think
Yeah.
she likes
No,
you
no.
and Ashley, and she likes talking about these things. So
But she was also a part of the astrophysics
she
discussion.
was, she was.
Yeah.
I know she's on
So,
it. Okay, cool, cool. So we'll
cool.
plan on. I will send an email. I assume that works for Ashley because it sounded like it did. So I was going to suggest
Cool.
maybe a coffee shop in Hillsborough because Ashley's in Beaverton. So maybe we could sort of meet partway in between,
I
like
literally,
like Grand
I
Central,
was
maybe.
literally thinking, well, I was thinking, actually, Grand Central would be cool too. Um, when over the summer before I came to New York, the coffee shop that I went to was Insomnia Coffee, which is in
Oh, okay. Well, that'd
Hillsborough.
be fine too. Yeah, either one.
So, but I mean, also I went there all the time, so Grand
Okay.
Central would
Okay.
also be probably novel and
All right.
cool. So
Well,
I'm
I'll
down
suggest
for
we go to one of
anyways.
those and see if Ashley has a preference or whatever.
Cool.
All
Okay.
right.
Cool. Cool.
Cool.
Cool.
All
All
right.
right.
Thanks for the fun
See you
conversation, Logan.
soon.
Take care. I'll see you
Of
soon.
course. Thank
Yeah.
you, Todd, for the
Yeah.
advice.
Okay. Yeah.
All right.
Bye.
Bye.